we are on what chapter are we on? 11. Chapter 11, section 3. I'm going to be looking at circles. Now, one of the things I hope you have caught on is we're developing, where do we get these formulas from? Why do they exist? Where do they come from? So let's look at the area of a circle. Now, some of you might remember what the area formula is for a circle. What is it? Pi times the diameter is the circumference. Pi r squared. Pi r squared is the area. And circumference can also be 2 times pi times the radius. All right, so here we have this circle that has a radius of r, and it has a circumference that goes all the way around like all circumferences do. So we are going to straighten that circumference out. Let me try it again. Here we go. We're going to straighten it out. Boom. There is our circumference. Now, how do I find circumference again? What's the formula?
Straighten it out.
2 pi r. There's one. In fact, we are going to be thinking about that one. 2 times pi times the radius. That is the circumference. So we will remember that. Now what we are going to do is we're going to dissect, and when we dissect in things like physics and math, it doesn't stink like some other unnamed classes. All right. So we're going to dissect it. We're going to dissect it into, not 12 parts. I'm going to dissect it into 6 parts right there. And then I am going to rearrange these parts. So let me get out of the way. I'll do it with the mouse over here so I'm not standing in front of it for you. So I'm going to start unfolding this. Let's take that back again. I am going to unfold this. There we go. So here it goes. See, there's all those pieces. We're just taking them out. And then we're going to stick that half back together. Now, that's kind of bumpy, so maybe let's stick it back into a circle and let's chop it into a few more pieces. Let's go to 12 pieces right there. So let's try that again. So I'm going to unfold it, and then, and by the way, this length is how much of the full circumference when I just go here? That'd be half. So I've got the red half and I've got the blue half here. And then we're going to put that one back. Hey, that's a lot straighter, isn't it? In fact, what shape does it kind of look like? A parallelogram. Kind of looks like a parallelogram. Now, I'm going to start with more parts, but I'm not going to put it all the way back to a circle. I'm just going to leave it here, and I'm going to do more parts. You notice what's happening to the straightness of it? It's straighter and straighter and straighter. How do you find the area of a parallelogram? Base times height. Now the base of this is how long? Half the circumference. If you took half of 2 pi r, what would you have? Pi r. Pi times the radius. That would be my base. Now what is the height of this parallelogram? The radius. Remember these little pieces of pi here? That's the radius. If you took pi times r, it's the area of a circle. And the more pieces you put it into, the more perfectly it fits into a parallelogram. In fact, when you get more and more of them, the more perfectly it becomes a rectangle, which is also base times height. It works the same way. So there is one development of the area formula for a circle. That's kind of cool, isn't it? And if you want to look at that later for your own, well, you can click on that when you go to Google Classroom. It'll take you a link to that same page so you can play around a little bit on your own. So they're doing the same thing here with the static image that I just did with that dynamic image, the image that moved. And if you don't have this memorized, make sure you do from this point forward. Area of a circle is pi r squared. Simple formula. What's the area of the circular cutting Green shown to the nearest foot. That 20 feet happens to be what measurement? The diameter. So what is my radius? Woo, good, you're smart. So if I want to find the area, pi times 10 squared, what's 10 squared? This is the exact area of that putting green. Leave it in terms of pi, and it's the exact area. Just like we have the square root of 2, that's the exact value. So if they ask for an exact value, there is our answer to it. If we want an approximate value to one decimal place, pi is 3.14, right? All right. So if I multiply it by 100, 314.2 feet squared, there would be rounded to the nearest 10. 314 feet squared. Find the radius of a circle that happens to have an area of 95 square centimeters. Okay, well here's our formula. Area equals what? Pi r squared. So they want us to figure out what the radius is, and they told us the area was 95, so our 95 goes right over here. I'm trying to solve for the r, the radius. What do I do first? Divide by pi. Now I'm not going to go to a calculator yet. I'm just going to leave it there. Then what do I going to do? Square root. So if we're going to get the radius, now we're going to go to a calculator. We're going to take the square root of whatever 95 divided by pi is, and I guess we'll go to the nearest 10. 5.5 centimeters. All right. The area of a circle is 196 pi square yards. Find the diameter of that circle. Well, again, I'm going to start with my formula. Area equals pi r squared. Area is 196 pi equals pi times the radius squared. What do I do next? Yeah, those pi's would just cancel out. I'm really dividing both sides by pi. So we get 196 equals r squared. R equals the square root of 196, which is 14. Now, what is the answer? 28. This is a diameter, a linear measurement, yards. It's not area. 28 yards. Okay. We already had a formula from last chapter to figure out the length of an arc, not the measure of an arc. An arc is measured in degrees. The length of it is going to be in linear units, inches, centimeters, things like that. And the length of an arc is just a fraction of a complete circumference. The same idea works here. If I want to figure out the area of a sector is that piece of pizza or a piece of pie or whatever you have in circles. So if I want the area of that sector, it's just a fraction of the complete area of a circle. And how do I figure out what fraction it is? Well, I figure out how many degrees that central angle is, which is the same as how many degrees this arc is, either one. And that fraction out of 360. So right here, the area of a sector is x over 360. X is the number of degrees we have in the central angle, or the arc, times the area of a circle, pi r squared. So it's the fraction of the area of a circle. A circular pizza has a diameter of 12 inches. It's cut into 8 congruent slices. What is the area of one slice? To the nearest 100. Okay, well we know the area is going to be x out of 360 times pi r squared. So how are we going to figure out what x is? 360 divided by 8. A full circle is 360. We have taken one of those pieces. What is 360 divided by 8? 45. Now, I want to actually think about this fraction a little bit more. 45 out of 360. That's the fraction that we have. What do you get if you reduce 45 over 360? You get 1/8. The fraction that we have right here is 1/8 of the full circle. We cut it into 8 pieces. So this actually goes back down to 1/8. But it would still work if we left it 45 right out there. Times pi times the radius squared. What's our radius? 6. Because the diameter was 12 inches, so our radius is 6. Now I'm going to do this and get the exact area, and then we're going to go to our nearest hundredth. What is 6 squared? 36. So if I have 1/8 times pi times 36, what can I reduce? What goes into both 8 and 36? 4 does. 4 goes into there twice. 4 goes into 36 9 times. So I would have 1 times pi times 9, or 9 pi over 2. And that would be, what was our measurement in? Did they tell us? Inches. There it is. Inches. That would be an inches squared. That would be the exact area of it. Since they said to the nearest hundredth, what do your calculators say? Nearest hundredth, 14.14 inches squared. Question?
So, to get the 1/8.
Well, to get the 1/8, I figured out how many degrees I'd have in the slice, which is the whole thing, 365 to 8, 45. Now, if you reduce this, 45 goes into itself once, it goes into 360 8 times. But there's another way we could have known that answer.
Yeah, I was going to say,
If they already tell us that we've divided it into 8 congruent pieces, then you can start right there, 1/8. That's our fraction. Yeah. I'm using the 45 because that's what we often have to do, because this is a formula that's going to do it. The x over 360 results in the fraction of the circle. Usually they don't tell us, oh, we have 8 exact pieces. So we just have to use the degrees. Find the area of the shaded sector. Like right here, we're just going to use the degrees. Now our formula is x over 360 times pi r squared. So what's our x? 53 over 360 times pi times, what's our r? 4 squared. I'll let you go to a calculator. They want it to the nearest 10th. All right. 7.4 feet squared. This is an area of a sector. Okay, so if we try this one, well, again, we know x over 360 times pi r squared. What is x? 148 over 360 times pi times 6 squared to the nearest 10. How much are you getting? 46.5? Meters. 46.5 meters squared. So, what's our angle? The x. Where'd you get 295 from? 360 minus 65. Our angle that we are dealing with is this. That's the shaded sector that we're trying to figure out. So 295 over 360 times pi times 11 squared. 311.5 inches squared. We gotta keep these circles around. They're easy. The color wheel at the right is a tool that artists use to organize color schemes. If the diameter of the wheel is 10 inches, and each of the 12 sections is congruent, find the approximate area covered by the green hues. See if you can do the fraction without going to the degrees this time. What fraction do I have? 1/4. 1/4. Isaac, where'd you get 1/4? That's right. I have 3 1/12s. There are 12 sections. 1/12 plus 1/12 plus 1/12 is called 3 12s, which reduces to 1/4. Times pi times what's r? 5 squared. So the exact, it's really easy to get the exact, 25 pi over 4. And we'll approximate nearest tenth. What do you get? 19.6 inches squared. Boy, this is going to be an easy Friday, I think. Worksheet and then bookwork. We'll uncover the bookwork. I'll find the worksheet. Where did it disappear to? Here we go.